All right. Well, thank you
All
everybody for
right.
joining us. We're super excited here. We have an awesome panel here for our DoK Town Hall, where we'll be discussing the database patterns white paper that was in collaboration with the CNCF storage tag. So, yeah, we have four great panelists who are authors of the paper. And yeah, before we get started, I'm going to just go over a few community things about what happened at KubeCon and what's to come. So, oops. First, I want to just give a big thank you to our community gold sponsors, Google Cloud and Percona. So thank you for your sponsorship. We really appreciate it. I want to do some community spotlights. So these are four of our DoK ambassadors. So if you haven't seen Gabriele Bartolini, he's been publishing a ton of articles on Cloud Native PG. All of those are featured in the DoK library, so you can find them there. I want to thank Olivia Rakshit from Avesha, who she recently just delivered the keynote session at KCD Pune in India. So that's really great. Robert Hodges, one of our other ambassadors, he presented at DoK Day, a lightning talk, and also participated in our DoK panel at KubeCon. And then lastly, Edith Puya, who moderated the DoK panel at KubeCon. So that was great. We had a really awesome time doing that. So thank you to them. So yeah, DoK Day at KubeCon Europe. The replay is available. If you scan the QR code, that'll take you to the CNCF YouTube page where you can watch all the talks. We had a record attendance, which was really awesome to see. We had peak attendance of 434 people, an average attendance of 175 people. So you should definitely check out that playlist if you weren't able to make it to Paris. There's a lot of really great content. I want to highlight the Data on Kubernetes panel that took place at KubeCon. That was moderated by Edith, and we had panelists Robert Hodges, Clayton Coleman, and Piotr from Percona. You can also check that out. The replay is available if you scan the QR code there as well. And then we have KubeCon North America coming to Salt Lake City, Utah. That's going to take place on November 12th through 15th. We plan on being co-located with KubeCon North America, but we'll find out next week. And if that doesn't happen, we'll definitely have an event in parallel with KubeCon North America. So we hope to see you there. I want to call out the next town halls that we have coming up in May with Steven Sklar, Senior Cloud Engineer from QuestDB. So you should check that out. You can scan that QR code. There's a lot of QR codes in this talk. If you want to register for that. And then also in June, we'll have Tang Lei from the Senior DevOps Engineer at Grab. If you're not familiar with Grab, they're like the Uber Eats of Southeast Asia. So that'll be an awesome talk in June as well. And then finally, if you want to get involved in the community, you can scan that QR code. It'll take you to the community page of the website. And if you're interested in sponsorship, you can scan the QR code on the right. All right. Well, those are all the community announcements. Let me stop sharing my screen. And yeah, I'll be moderating discussion today. And we're going to be talking about the database on Kubernetes white paper. And as I mentioned, this was in collaboration with the storage tag from the CNCF. And I'll kick it off by announcing our panelists. So we have Xing. Do you want to announce yourself and tell us a little bit about yourself?
Yeah, sure. My name is Xing Yang. I work at VMware by Broadcom in the Cloud Native Storage team. I'm also a co-chair of CNCF Tech Storage and Kubernetes SIG Storage.
All right. And then next we have Leonardo.
Hi, Leonardo Cecchi. I'm an engineer working at EDB. I work on Cloud Native PG, an operator for Postgres in Kubernetes. I'm a maintainer. And I work for Big Animal, which is the DBaaS offering of EDB2.
Thanks. All right. Next we have Patrick.
Hi, I'm Patrick McFadin. I work at Datastax. Probably know me from a book I did last year, managing cloud native data on Kubernetes. Been pretty active in running databases in Kubernetes for a few years now.
All right, and last but certainly not least, we have Alvaro.
Hello, everybody. I'm Alvaro Hernandez, but most people call me Alvaro because that's just easier to pronounce. It either works for me. I am the founder of a company called OnGres, which means on Postgres. So it's pretty obvious what we do. In the cloud native space, we have developed an open source platform for running Postgres on Kubernetes called StackGres. This is essentially the stack of components that you need to run on top of Postgres for making it production quality, which obviously runs on Kubernetes. And I'm also the founder of an international nonprofit foundation in Spain called Fundación PostgreSQL that aims to promote Postgres internationally and organizes events like an international conference in September for those who might be interested.
Awesome. Well, thank you everybody for joining us. I'm going to start this panel off by asking a question to Xing. So Xing, I know this topic sort of started with a discussion between you and Melissa Logan. So what drew you to the topic and what were you hearing that led you to pursue this project?
Yeah, so I read the DoK survey, which showed that more and more stable workloads are running on Kubernetes, including databases, data analytics, and so on. And Tech Storage also published a white paper a couple of years ago on CNCF storage landscape, which included a section on databases, but that was not in depth. So I thought there are lots of practitioners in the DoK community who have the experience of running data on Kubernetes. It would be great to have Tech Storage and the DoK community collaborate on a white paper that describes the patterns of running data on Kubernetes, focusing on databases first. So I discussed with Alex Cherkov, who is another Tech Storage co-chair, and Melissa Logan. Both of them loved the idea. So that's how we got started to work on this paper together.
That's great. Yeah, I think it's proving to be really useful and has a lot of really great information. So yeah, let's start off the conversation we'll ask each of our panelists. So databases have been the #1 stateful workload run on Kubernetes year over year, according to the DoK survey. So what are some of the key benefits of running databases on Kubernetes compared to traditional deployment methods? And we'll also touch on what are the challenges, but first I want to hear what are the upsides. And I guess I'll start with Leonardo.
Hi. In my opinion, Kubernetes is a really great platform for applications. And I'm using the words of Alex Cherkov here because I totally agree with him that every application is somewhat stateful. It totally depends on how you have to pay to rebuild your state. So it's not being stateful or stateless. It's actually a shade of gray. And I think Kubernetes is great for every shape you think. This is especially if your application are already hosted on Kubernetes. You will gain many benefits. Just to be on the practical side, if you lose a node and you have Kubernetes on that with an operator, you have someone that is creating you another node, cloning all the data, and we quickly recover from the situation. And also for day-to operations, something like backups, monitoring, patching, updates. So everything great is really great if you use operators to do that.
Oh, great. Thanks. And Patrick, what do you have to say?
Oh man, why is that a good idea? Because it's hard. Yeah, I come from a Cassandra background. I'm also a Cassandra committer, and I just as a mode of endorsement, Datastax, we run our Cassandra service, Cassandra as a service in Kubernetes, and the reason we do it is because that's the way that it's most reliable. And of course, I work with a distributed database. That means we distribute a lot of it, and there's tons of little things: security, networking, storage, all of those things. It would take a team probably 5 times the size that we have if we had to do everything through a command line. And it's all pretty magical whenever you get it right. And I think that's the key. You got to get it right. But we've spent years, and so this is not a conversation we had a few years ago. If you're starting today, Thank you. You're welcome. There's been so much work, everyone on this panel and others that have done to make this easier, but it should be easier. So that's the advantage.
Yeah, and that's definitely something I think we're trying to do as a community, is make it easier. All right, Alvaro, what can we hear from you?
Well, actually, Leonardo and Patrick just stepped over my answers already. So instead,
you can go first next time.
So instead of reinforcing that, I think it's very clear already, and I'll just briefly summarize that on what Leonardo said. My two main advantages are actually resiliency, because there are some auto healing capabilities built into Kubernetes and operators that can make things reheal automatically, much easier or much more doable than on-prem or the environments. And the other one is around automation and day two operations. And on what Patrick said, it makes things that are complex much easier, especially through operators. So instead of reinforcing this, let me tell you a couple of very quick stories. The first one is about this last topic. We developed a software for Postgres running on Kubernetes for one of our customers. And there was some hesitation about using Kubernetes. And at some point they said, okay, you know what? We really want VMs. Let's drop this Kubernetes thing you're building. Just bring it back on VMs. I went back to my team and I said, okay, this project took 4 months to develop. Now we need to, and I knew the answers. I was kind of mocking them a bit in a good way. And I said, now we need to remake it in VMs. So it took us 4 months to develop, including the software in Kubernetes. Then my team came back to me and said, okay, now we need 9 months. So Kubernetes can make complex things much simpler. Kubernetes might be perceived as complex itself, but it really depends on the surface area you're interacting with. But at the end of the day, can make things much simpler. The other story is actually how we came with the Stackers. We were doing, Postgres requires a lot of components next to it to run, connection pooling, high availability, backups, monitoring. None of this is included with Postgres. You need to bring it together from the ecosystem. We spent so many years deploying Ansible and IAC. We've been always great fans of automation. But we realized that from environment to environment, we were not reusing our code. We were not reusing, there was a bit of copy and paste and then modify, but it was not really maintainable code. And at some point, we started thinking how we can deploy this stack of components, we call it that way, that Postgres needs alongside all of these tools in a way that we just don't need to go environment by environment, creating custom code essentially for every customer, how we can deploy this stack in a uniform way. And after thinking, one day we said, hey, this Kubernetes things, it happens to have an uniform API. And this API abstracts away the infrastructure, compute, storage, and network. And then it depends on the administrator that will map this to the real infrastructure. So why don't we create this single installable package on Kubernetes so that it will apply to anywhere? And that was the real motivation behind it. And I believe, in summary, this is one of the greatest advantages that makes the infrastructure uniform and makes the infrastructure programmable, which leads to automation of day two operations. You might say, oh, but you can also do this in the cloud. There's also APIs in the cloud to abstract that away completely. And that's true. But how many clouds are there? So are you going to create your automation for AWS or Google Cloud or Azure or Oracle or all of them? It's a huge effort if you need to make it for all of them. Kubernetes, you just have one of them and it will run anywhere. So it makes things economically feasible. And now you can automate and program against that to make your deployments, your operators work, and they will essentially be able to run anywhere. For me, that's the main key advantage.
Yeah, that's really interesting. It's like the ultimately the getting started is challenging, but it makes other things easier. So that's interesting. All right, Xing, you have the opportunity to give the final remarks on what are the benefits.
Yeah, so I definitely agree to what everybody have already said. So running databases on Kubernetes can leverage Kubernetes declarative APIs. You can reconcile the actual state of the database with the desired state. So you can leverage Kubernetes self-healing abilities, built-in scalability, multi-cloud or cross-cloud portability, rapid iteration, agile deployment, and running databases on Kubernetes also is typically facilitated by an operator that can automate your data operations, such as backup restore, migration, upgrade, and so on. And you can also leverage third-party tools from the ecosystems such as Prometheus and Grafana for monitoring. And if you already have the rest of the stack running on Kubernetes, it's better to also move your stable workloads there so that you have consistency throughout the environment.
Okay, thank you. Yeah, those are all great responses. I guess we'll go in the same order to now we talked about the good. What are the challenges you face in running databases on Kubernetes? So we'll start with Leonardo again.
Oh, no challenges. No, I'm just joking. There are challenges, yes. Well, you know, in Kubernetes it's not an easy platform. It's difficult to learn, difficult to understand. These days, there are many resources that you can use to. But still, in my opinion, knowledge is one of the challenges. If you're going to run databases in Kubernetes, you really need to know your Kubernetes cluster and your database too. You cannot delegate everything to an operator. This is not how it works. There is still roles for DBAs these days, because actually databases need to be managed, to be designed, need to be handled correctly. This knowledge is like a puzzle. To really appreciate it, you need to have every piece. But there is also, I mean, it's still better than a puzzle, because if you don't have a piece, you can build it yourself. So you said, oops, I lose something, then I cannot build it anymore. No, now you can. And especially in these times, so it's great. Then I leave to the other guys the most. This is my experience, say. I'm not going to the technical side, because I think every solution has different aspects.
All right, thanks, Patrick. What do you see are the main challenges?
It's just anything that's new, especially, is you're going to make some decisions that are probably not right for the environment you're in. And I see people trying to run databases like they've always done, and like take a hammer and try to shove it into Kubernetes. Like, I mean, the first thing I see people do, whatever that are new to Kubernetes and running databases, is like, how do I get a command line? Like, how do I get into the database? Or how do I connect to it? You know, like, well, did you set up an ingress point? What? So, I mean, that's a huge challenge, and it does take a bit of work to get past that initial learning set that you have to do. It's not crazy. It's not anything that you haven't done before, but it can become a challenge. But it's also a downside, because you're going to create technical debt early. And, you know, when you see people just creating an open ingress route or something, that's not the right way to do it. And eventually you're going to have to fix these things. So start early. And it's not premature optimization. It's learning how the thing that you want to do fits in the tool that you want to use. And you know, that can, and it could stop teams. It can make teams stop doing it, because they're like, well, wait a minute, this is too complicated, or why would we ever want to do this in Kubernetes? It's so complicated. Yeah, a lot of things are that way. You know, when I first started, you know, programming, it was so complicated. Why can't I just talk to my computer? Well, it turns out in 1980s you couldn't yet, but but now we can. But yeah, I think that's a little more less technical reasons, but very real reasons. These are institutional issues you have to get through.
Yeah. Okay. So Patrick's advice is just do it right the first time.
No, do it right. Do it 3 or 4 times, and you'll get it right the final time.
Yeah. Okay. Yeah. All right, Alvaro. What do you see as the main challenges?
So there's definitely some social or learning challenges, but there's definitely also technical challenges, right? I think we all love here Kubernetes, but Kubernetes is not perfect either. And to adjust to stateful workloads and particular databases, there are some technical challenges that arise. Let me just mention one that is quite easy to understand. Many databases have a pattern where there's like kind of one node that accepts reads and writes, primary node, And there are other nodes that are replicas that just accept reads. So this introduces a difference between the nodes that Kubernetes currently does not account for. And when you set up, for example, stateful set, and Kubernetes needs to wipe out one pod because of resources or because of whatever, right? It might choose any, and you want to choose some particular node. And definitely, you want not to choose a primary. If there is one node that needs to be sacrificed, you want that to be a replica, not a primary. Kubernetes does not understand this concept. There's no such thing as a primary replicas aware stateful set, even though that's a pretty good idea that someone will build one day, specifically as an enhanced or optimized stateful set for Kubernetes. Is something we have considered internally to do at one point. So there are certain things that you need to do for your database to run operationally well or better in Kubernetes. There's all the things you need to tweak. For example, in particular for Postgres, you need to tweak settings around shared memory. You need to tweak settings about pod disruption. So there's a certain amount of things that you need to do in order to run your database well on Kubernetes. This is what I usually call a slightly twist Kubernetes arm, right? Like, I mean, it works and it works very well, but you need to do certain patterns. Now, the good news, and I don't want to jump into potential future topics for today's discussion, but the good news is that almost all operators I know have done this work already for you, and you don't need to worry about this. And therefore, my takeaway is that if you want to run a database on Kubernetes, it's very likely a bad idea to do everything for yourself from scratch. And rather, it's a much better idea to rely on something like an operator who has encoded already all this knowledge and knows how to twist this Kubernetes on.
Yeah, definitely. We'll definitely get into the operator discussion in a little bit. Okay, Xing, final response to the challenges.
So day-to-day operations such as the upgrade, of course, that's very challenging when you run database on Kubernetes, but that can be mitigated by using an operator. And the other challenge, as others have already pointed out, that's the complexity. It's definitely takes a long time to ramp up. If you are new to Kubernetes, it takes a lot of time and effort to manage data workloads running on Kubernetes. And it's complicated to integrate that with your existing environment. And then the other challenge is the lack of people who have the skills to do the job. Another thing is that in a Kubernetes environment, there are a lot of components, so debug could be more challenging. So it is important to have your observability built in so that it can help you detect problems early and prevent failure from happening.
Yeah, well, you mentioned the shortage of people with expertise. Well, hopefully, it seems like that's the number of people who are doing it are growing. As we saw at KubeCon, there were 12,000 people in Paris. So hopefully those roles get filled. So I'll probably just ask maybe any of you who feel specifically opinionated about this, but are there any specific considerations or limitations for different types of databases, relational versus NoSQL, et cetera? I'll open it up to anyone who wants to respond.
Well, I'll jump in on the NoSQL side. I mean, I think one of the considerations that we had to think hard about in an operator is the concepts of building a cluster database and a distributed database. One of the key features of Cassandra is it's multi-data center. I mean, that's the way you should build it. That's a hard concept because a Kubernetes cluster is pretty isolated, and being able to transit from one Kubernetes cluster to another, there are projects and we've worked through it, but that did not fit into the Kubernetes mindset. And so we had to separate the control plane from the data plane to make that work right. But and that's in the Cassandra operator if you're interested. But yeah, I think that just understanding that you're deploying a cluster, and the thing that, like, I'm mentioning all these things which are really around DR reliability and things like that. be careful, because when you're building a distributed system inside of a distributed system, is it distributed? You could have a Kubernetes cluster and think that you're safe and it's running on one piece of hardware. That was actually, I think it was a DoK from a long time, a DoK presentation from years ago. It was like, with one command, you could wipe out your entire data center. And so thinking about, we try to work hard on making sure that the database is fine, but you also need to think about the Kubernetes side. Like, how is that working? But that's a particular challenge in the NoSQL world.
Actually, Patrick, I did once and wrote a blog post, kind of a game, but I ran a 63-node Kubernetes cluster inside of a single physical VM, right? That's not very
so
dangerous.
At all, right? That's so dangerous. Yeah.
No, actually, I wanted to piggyback a little bit on what you said, that the DR story is a bit complicated. Actually, we face the same problem for our Postgres operator. And how do you do a DR where you see a single logical view of the cluster that is spread across two Kubernetes clusters? And the answer is essentially you cannot do that. So we had to twist the arm here even a bit more. And we have now implemented the functionality that the high availability system that we typically use for Postgres that relies on a distributed consensus store like etcd. Normally it piggybacks on Kubernetes' own etcd, right? So it's local to the cluster. And this is very convenient because it draws no more resources and requires no more dependencies. But then it doesn't work well in the multi-data center story. So instead, we have opened up the option to use an external etcd. So if you can have like global across regions, at least etcd, which is also not, it's a bit of a challenge on itself, but it works. And then you can have a single logical view of the cluster that is spread across more than one Kubernetes cluster. And this is definitely a challenge and a difficulty in this regards. The other one that might be more specific to relational databases more than NoSQL databases, that resonates a little bit with your original statement or question, Paul, is that most relational databases use a TCP protocol that is not HTTP, and most, not all, but obviously some NoSQL databases use an HTTP protocol. When you want to expose this outside of the Kubernetes cluster because you want to interact with workloads that don't run on the Kubernetes cluster itself, well, HTTP turns out to be quite easy to expose. Patrick said it, Ingress, you're done. But you cannot do this with TCP because Ingress does not speak TCP. I mean, it does be HTTP, but not for TCP. So you need to rely on all the mechanisms like exposing via node port or load balancers, which are not ideal always. Or finally, there's not the new gateway API that can fix this. But before that, it was a bit harder. So it was a bit challenging. And this may not happen on most databases that are exposed over HTTP.
All right, thank you. Well, I want to move on unless Xing or Leonardo have something that they're itching to say. All right, I will offer the first. I'll let Xing respond to the next question first. We'll go in reverse order. Make it hard for Leonardo here. So yeah, we want to move on to an important topic, which is operators, which we already sort of touched on. But a few years ago, the results of the DoK survey showed that the overwhelming majority of people felt the operators were not quite mature enough and they were quite up to speed. So since then, we've seen the operator landscape has matured quite a bit. What do you see that has improved, and maybe what still needs a little bit of work? And so we'll start with Xing.
So from the DoK survey, we know that users have very high expectations of the operators. So now we see Kubernetes functionalities are getting more mature, and that also helps the operators to become more mature. Operators are used heavily to handle data operations, for example. We see that operators are doing better in this area, handling migration, upgrade, backup and restore, and so on. And also CNCF has an ecosystem that has a lot of available tools. For example, you have Prometheus for monitoring, Fluentd for log processing, Argo CD for declarative continuous delivery, and many more. And all of these third-party tools can be leveraged by operators. And on the other hand, lack of standard is still a problem for the operators. Another problem is that managing operators across multiple Kubernetes clusters, that's still difficult. So tools are still evolving in this area.
All right, thanks. All right, Alvaro, what do you have to say?
Well, I think Xing painted it very well. One of the areas that I definitely see improvements is precisely by leveraging all improvements that came with Kubernetes itself, right? One example, for example, there's something that we have implemented Stykers and CloudNative PG implemented even before, is the use of snapshots for backups. So substitute for backups. It's such a game changer. The idea that you can take a backup of a multi-terabyte database in a few seconds, in a couple of minutes rather than hours, and restore time in also minutes versus hours or even days. It's definitely a game changer. And I don't know exactly the details on Cloud Native PG, but for us, it was quite straightforward to implement. I'm not saying this is a tiny effort, but it was not a big effort for providing such a great value. And the main reason is because it was implemented Kubernetes, and it's just an API away distance from your implementation from an operator perspective, saving, of course, a lot of cables. I'm not trying to oversimplify. But building on top of these Kubernetes features that are being added over time, volume expansion, for example, another one that is very important for databases, right, are making things much simpler for operators, which leads to operators that are much more capable and mature. And this is definitely a key area here. I also see, on the other hand, a little bit more proliferation of different solutions for the same problems, which is probably a good thing and it's probably a bad thing at the same time, right? It creates potentially a bit of confusion for the users, and it actually piggybacks also. You mentioned this thing on terms of different ways of doing things, which leads to kind of a little bit of different opinions that confuses users. So this lack of standardization is one of the challenges or problems that I see. And I would like to see a little bit of consolidation or working together on common solutions. To be more precise, operators are typically driven by their CRDs, the customer source definitions that they expose, and everybody's doing their own CRDs, which is more than fine, obviously. But at some point, I would like to see a little bit of collaboration in this regards, and I'm sure we all agree on this here, so that there could be, maybe not all of them, but some of the CRDs that might be common across operators, so that the knowledge surface for users to learn about is smaller, and we agree on common solutions to come up.
All right, well, I'll plug the DoK SIG then, where you all can participate and maybe we can work towards that. Which, yeah, come check us out next Tuesday. Join us on Slack. All right, Patrick.
Can you repeat the original question? Because my mind started wandering off when I'm listening to these other answers, and I'm like, you know what? I'm going to answer the wrong thing because I'll be responding to Alvaro.
Oh, sure, yeah. I mean, so really, we're just wanting to talk about, how's the landscape of operators matured, making things easier, and then, but what are some things that are still sort of challenges that could be improved?
Yeah. Okay. So, yeah, they have improved a lot, and I do think that we've gotten past the basics, and I agree with Alvaro. It's like we need to start pulling in like all the separate things. But what I see is an interesting opportunity, and here I'm gonna add those two letters that everyone wants, is this stuff that around AI right now, which is really interesting. We talked about the level 5 operator, which is the full automation of things like being able to scale up, scale down, make decisions, decision support, that sort of thing. It's interesting how that is now much more of a possibility. And I wonder when that's going to start showing up in operators. It's not something I think everyone's going to jump into right away, but I'm kind of excited by the possibility. And I touched on it in my book at the last chapter. The last chapter is where I was dreaming. I was having a hallucination, but it was more like looking into the future. If we're truly determined to reduce toil, and that's what we're trying to do, is reduce toil. Kubernetes, using operators reduces toil. Then it's very easy to see how operators are going to get smarter and have more agency. They're going to be able to make decisions in an automated fashion. And I think that's going to be really interesting to watch. You should be able to declare things and have them emerge.
Yeah, awesome. All right, Leonardo, last answer the question.
I totally agree with the others' opinions. I think operator got better because we, as a community of operator developers, are learning, and this is what it's happening continuously. And so it's not only because of us, but because the database community, I'm mainly referring to Postgres here because it's my main area of knowledge, is starting opening itself at the reality we have here in the cloud native space. So we are starting mixing each other opinions. And this is a thing where we should go together in just one place. And this is happening right now. So there are beautiful things to come. And yeah, that's it. Just to spend a few words about what Alvaro said about the standardization of CRDs. This would be totally great, and what we have now is different CRDs for different solutions. But let me flip the coin. Having different solutions is also really inspiring. And it is enriching us in this moment. So after this period of enrichment, there may be the period of consolidation in the same place, but we actually need both.
Yeah, that's really interesting. Well, thank you everybody for answering that question. I think we're going to push towards what is the future. So as we saw at KubeCon in Paris, the sort of word of the day was AI ML. It's obviously a very hot topic. And obviously AI requires a lot of data, and that's driving a lot of people to Kubernetes and data on Kubernetes community right now. So what are you all hearing as key opportunities and challenges of how will that affect the future of DoK? And since I guess I'll start with Patrick, because you've been in the middle the whole time.
Just give me the lead, huh? Oh boy,
Yeah.
I hope I don't make a mistake. Well, we were talking about this before we started. GTC a few weeks ago, NVIDIA GTC, they announced a Kubernetes-based system, and it was to run inference and inside of your own Kubernetes cluster. It's Kubernetes operator, but it uses NVIDIA GPUs. There you go. They've clearly they know where they're going. They said use Kubernetes. And that was really cool to see that little Kubernetes logo up there on the slide. But I think the thing is that the workloads, I mean, the data is still going to be the same. If you run Spark, that sort of thing, data is still the same. Still going to have the same problems. The newer problems that are going to be, I think, have already been talked about and addressed in some way, but it's adding GPU to the mix. And adding GPU requires a different kind of scheduler. The good folks over at Unicorn, Volcano.sh, their schedulers are purpose-built around not only CPU, but GPU. And these are things to think about, right? But GPU is now becoming a really critical part of not just analyzing data, but also serving data. And I see there's the Voltron just announced, their GPU accelerated query engine, and I'm sure that will run fine in Kubernetes. So if I had one word or three letters to use, GPU, how are you going to deal with it?
All right, thanks, Patrick. Okay, Xing, so what are you hearing as key opportunities and challenges that will affect the future of DoK?
Yeah, so definitely at KubeCon heard a lot of AI related topics. So see that Kubernetes is becoming a default platform for data and AI machine workloads. OpenAI started to use Kubernetes to run their AI machine workloads as early as 2017. At that time, they had to write their own autoscaler. Now we have an autoscaler in Kubernetes that we can use. So a lot has happened in the 10 years since Kubernetes birth. Kubernetes is getting more mature. And now with generative AI, we have even more unstructured data. So how to load the data faster, how to cache data to improve the performance, how to enhance the scheduler for parallel processing. And also there are concerns on data security and data governance. So there are a lot of challenges. And with those challenges, we also have opportunities. So right after KubeCon, there is a new initiative to form a new working group in Kubernetes to make it the best platform for accelerated workloads. And in SIG storage, we are working on moving the project Cozy to beta. Cozy tries to make object storage the first-class citizen in Kubernetes. And as you know that object storage has been a popular choice in AI machine learning, so this project is pretty important. Yeah, so to Patrick's comment on the GPU, definitely we see a shortage of that. So yeah, how do we have enough of that, right? So at KubeCon, I heard people talking about how to use CPU and GPU together, how to attach CPU machines to GPU machines, and use CPU machines to do certain things like loading and pre-processing and make your data ready, and then use your GPU. So there are a lot of things going on. Definitely a lot of opportunities moving forward for DoK.
Yeah, so it's an exciting time. All right, Leonardo, what are your opinions here?
In my opinion, what I expect to be is that we need to improve our databases. That's it, especially regarding to storage, because everything is beautiful, but this all depends on data. And speaking as a Postgres user for a long time, we have this axiom that once you have synced, no one is going to forget your data. And perhaps we should be prepared to manage different storage with different guarantees, with different performances, and different pattern of operations that are preferred to them. So what I think we should do is just to expand our point of view, because there are now different type of storages. It's not just your block storage, it's your object storage, is maybe the storage you have in a totally another region, and then be prepared to work with them to expand our system to cope with, actually to be enriched with all the storages we have. This is going to be a challenge for traditional databases, but it's also a really beautiful challenge to accept.
Yeah, well, I think there's a growing community around it to help accept it. That will accept that challenge. And then Alvaro, I'll leave it to you to give the final remarks on the key opportunities and challenges of how will affect the future of DoK.
Yeah, I guess there's a few of them, but let me focus on one in particular, which I hear more and more from users and customers, and where Kubernetes in general, but containers in particular, can play a key role, which is security. There's been, is back in our minds, all these recent events and these problems that I've seen with dependencies and whatnot, right? And the technologies and the ecosystem around containers has developed so much that it's starting to produce very good quality solutions for mitigations or partial mitigations for some of these problems, which are hardly present in non-Kubernetes environments, and that's the key. For example, container images themselves are immutable. It's a pattern where you're kind of assured that if you trust a given image, then you know what you're running. And this is doable also in non-Kubernetes, non-containerized environments, but it's non-trivial and it's not standardized, right? Versus in Kubernetes, this is almost, you know, our daily basis. So there's tools for scanning security vulnerabilities of containers. There are tools for digitally signing containers. This all goes in the way of assuring what you're running. What is it? The workload you're running is what you expect to be running. But there is more. There's tools for generating and validating SBOMs, the software bill of materials. document, machine readable document that specifies the dependencies and the versions and the provenance of all the components they're using inside of that container image. So I'm not going to say that it will prevent supply chain attacks, but it definitely helps mitigate or reduce them. There is tools to provide all the kind of attestations as to how the software you're running has been built and distributed. And all these tools are now integrated into the Kubernetes ecosystem. Again, none of this is exclusive to Container Vault or Kubernetes. You can do this without, but it will be much harder because it's not standardized or part of this ecosystem. Tools are built for this, which piggybacks on the original comments we were having at the beginning of this talk that Kubernetes is essentially an API. And as long as you can program against this API, you can automate and create tools that will work with this ecosystem. So I see that there's a huge opportunity in security versus non-Kubernetes areas where we may be able to present software databases run by operators that provide some security warranties that are higher or much higher than on non-Kubernetes environments. And because this is becoming increasingly more important, it presents a significant opportunity for running important workloads like definitely databases on Kubernetes. And speaking of Postgres, which again, I'm sorry to piggyback, but this is my daily work, right? There is even an even particular issue that can be leveraged here related to upgrades, right? When you upgrade the database, there's some components in Postgres that might apply to other databases that rely on the system, rely on in particular the libc of the system, and they can go as bad as essentially creating silent data corruption if you don't do the things properly well. So there's a strong tie when you're running outside of Kubernetes between your libc version, which is your OS version, and your database. And by running in containers, you're breaking this dependency because when you pack in the container, you have full control of it and can be absolutely independent on your host OS. So there's opportunities in data safety and security, to summarize my opinion on this topic, that can be leveraged to provide greater sense of security and safety for users running database on Kubernetes.
Well, yeah, thank you. I wanted to hit the topic of security, but we'll have to maybe save that for another panel. That could probably be its own panel in itself. Well, yeah, I want to thank all of you for your very valued opinions. And I think we actually do have a few minutes for some questions. And some people have already asked some questions on our YouTube feed. And my new friend that I met in Paris, sorry if I pronounced your name incorrectly, Guillaume, was when we asked the question about challenges for different types of databases. He said, what about vector databases? So are there any sort of considerations for running vector databases in Kubernetes?
This is what I talk about every day.
Yeah, I figured you'd be the guy.
Yeah. Well, all right. So there's a few things here. On the dedicated vector database side, Milvus is a project in CNCF. So yes. And they have been in CNCF for quite a while. But it's also worth noting that every database on the planet now has vector as a feature. So I don't think there's a lot of considerations there. Other than the fact that you just need to make sure you're on the right version, Cassandra has a certain version that vector is a type, and Postgres has PG vector, etc. But yeah, the thing that is, I think one thing you need to consider is that you need to look at your resource management pretty heavily, because creating vector features inside of a database dramatically increases the amount of CPU and disk IO that can be used, CPU especially, because indexing operations on large vectors can be pretty costly. And again, we get back to GPU scheduler, anyone? But it's just something to pay attention to. Not all. I mean, if you're not using a lot of vectors inside the database, then it won't cause as much of an indexing load. But it does put a pretty significant load on the system if you're not paying attention. So just some things to consider. Mostly you'll be just fine if you're using a version of a database that has vector support.
All right, thanks for your response. Anybody have any more questions that they want to ask our panelists? We have a couple more minutes. Could probably answer one more question. I'll let it sit there for a second. And then once we finish up, we'll do a little quiz. We'll give away a DoK shirt, which I know is super prized possession. Let's see. Well, I think we're sort of wrapping up here. Yeah, so again, thank you so much for your time. Really appreciate it. All of your opinions. You all are very valued members of the community, and I think provide a lot of insight. So I think we'll go ahead and do the quiz. I think to my colleague here, Diogenes, will set that up, and we'll get that going. So get your smartphone out, because there's a QR code you can scan, and our participants, our panelists can also take part if you would like, and try and win a shirt. All right. So you can go ahead and scan that QR code. That should get you into the game. And we'll ask, I think, 4 questions. We'll see how much you're paying attention at the beginning when I was making the community announcements, because basically all the questions are related to that. So we'll give that a minute. Let's see who wants to play. And then I'll leave it to you, Diogenes, to okay, we've got 1. I think we need at least 1 more. Okay, we got 2. It's happening. We can give it a couple more minutes, or a minute or so. Okay. Well, oh yeah, right. Got a good group here. 6 players. All right. Let's do it. First question. If you answer more quickly, you get more points. Okay, we had another successful DoK in the books. What was the peak attendance on DoK Day? You have a range there, so it's easier. I know the exact number. Okay, everyone's voted. Cool. All right. Ooh, close, some of you. All right, next question. It was 434 people, and that was for Gabriele's talk, by the way, from EDB, who was an author of this paper, but he could not come today. So Leonardo's filling in for him, because he's an expert in the subject as well. All right, question number 2. Oh, we have an extra player. Okay, Tiger has joined. All right. Where is the next DoK Day taking place? This one should be pretty easy. Okay, we have San Francisco. That's where I am right now. Brooklyn, Salt Lake City, Las Vegas. Ooh, all right. Salt Lake City. That's the one. Most of you are paying attention. All right, we have 2 more questions. Oh, okay, we had some things got shook up there a little bit. Okay. Sean coming in strong. Okay. When will the next KubeCon North America take place? We have October. Oh no. Okay. Oh yeah. Never mind. Those are the right. No, those are the wrong. Forget the years. Just pick the month. That was a mistake. All right. Apologies for that. That was my. The month was what was important. Okay. I think we have 1 more question. Right? Or was that 3 or 4? Okay. 1 more question. Here we go. Who's going to get the shirt? Okay, yeah. Who was the moderator at the DoK panel at KubeCon in Paris? This one's a little tricky. Okay, it was Edith. Edith is our DoK ambassador. Did an awesome job. Robert was also there, but he was a panelist. So, okay, let's see who came on top. Ooh, Shami. Shami's the winner. Okay, Shami, you can contact me on Slack or however you want and reveal who you are, because I don't know who that is. And yeah, we'll set you up. We'll send you a shirt. Yeah, thanks to everybody for participating. And yeah, I really want to just say a special thank you again to our panelists. This was a really great discussion. I know you all are very busy, and I certainly appreciate your time. And everybody who joined us today, I know you're probably also very busy, but I think we had a great discussion. And yeah, I look forward to having more of these discussions in the future. So, oh, I see it's Chris Malarkey. You're the winner. Congratulations. I'll contact you and we'll get you the shirt. All right. So thank you everybody so much for attending, and I hope you have a great rest of your day.
Thank you.
Thank you, everybody.
Bye.
Bye.